So now, let us talk about the reactions of alcohol. So we have successfully completed the preparation. Now it's time to understand the reaction. Now, we are going to see some major important reactions and we are going to understand them with the mechanism. Alright, so be ready with me. So first we'll talk about the reaction of alcohol with acids, that is HX. Alright, now here in that we will talk about one special type of reaction which comprises of HCl. Alright, so what's special about this reaction? Now, let me show you the reaction and then we'll talk about what is special about this reaction. Okay, so here we'll start with simple alcohol. So here we have a simple alcohol, CH3, CH2, OH. Can you name this alcohol for me? 2 carbon, eth, alcohol, all. Yes, ethanol, very good. Now, this ethanol, we are going to react it with HCl, yeah, right? Okay, what will happen? There's nothing to be worried about. Nothing is very complicated. Look at this. Here we have, I'll use another marker. Here we have an OH and here we have an H. What happens when an OH comes in contact with an hydrogen? Yes, of course, they form water. So here you have water, H2O, very simple. Yes, very stable. Now, here we have a bond remaining and here we have chlorine. What will happen? The chlorine will now attack here to form what? Yes, CH3, CH2, Cl. That is alkyl halide. Yes, very simple. Here we have prepared an alkyl halide from an alcohol by using what? HCl. Now, so you talked about something special about this reaction. Please tell us. Yes, of course, I'm going to tell you what is special about this reaction. Now, reacting alcohol with HCl and a little bit of change in that can convert it into a very special reagent which is known by a name Lucas reagent. Okay, sir. What is special about this Lucas reagent? Now, hold on, I'll tell you what is special about this Lucas reagent. Now, let's say I have a primary alcohol, I have a secondary alcohol and I have a tertiary alcohol. Since you know all this alcohol have a colorless smell and everything, same properties, belong to the same family, how will you distinguish between this primary, secondary, tertiary alcohol? Sounds like a tough question, right? No, it's not. Lucky for us that we have a Lucas reagent. So now look what I am going to do. Lucas reagent is basically a combination of concentrated HCl and anhydrous ZnCl2. Yes, so you have here. So in the primary alcohol, if I'll add what? This Lucas reagent, we get nothing. Okay, let's heat it a little bit. Okay, you see turbidity? Yes. What happens if you have a primary alcohol and you try to react it with Lucas reagent? A little bit of heat is required and then you see turbidity after 20 to 25 minutes or 30 minutes max. This turbidity is a sign that you had a primary alcohol. You had a primary alcohol. Okay, so this is primary alcohol. What about secondary alcohol? If you have secondary alcohol and we are adding Lucas reagent to it, we get turbidity after say 5 or 6 minutes. Yes, quick, right? Without any heat. Alright, so here we have the second category. What if we have a tertiary alcohol? We are adding Lucas reagent, instant turbidity. Now, this information can be used to identify if the alcohol is primary, secondary, or tertiary. Alright, so if I have an alcohol and I add Lucas reagent, if it gets turbidity instantly, that is a tertiary alcohol. Good? Yeah. If it gives turbidity after 5 to 6 minutes without any heat, it's secondary. And if it does not give any turbidity in absence of heat, then it's primary alcohol. See, we distinguish primary, secondary, tertiary alcohol by using this Lucas reagent, a simple reagent but effective, right? Yeah, cool, good enough. Now, let us understand the mechanism, how all this taking place inside this beaker. Okay, now we're not talking about the Lucas reagent, we're talking basically about this reaction of alcohol with acids. Okay, so here, time for the mechanism. Okay, so let us write down the mechanism. So for mechanism, I am going to teach you one more important part which will help you in your competitive exam. So let us take the compound which is CH3 bond CH bond CH3 bond CH2 bond OH. Okay, here we have an alcohol. Now, in HCl, whenever they are going to react with anything, of course, since they are highly polar, they are going to dissociate themselves into H plus and Cl, that is cation anion, and H plus will come in contact with the alcohol first, but the attack will take from the electron rich species to the electron deficient species. Yes, always remember that. Okay, so here we have what? H plus. Okay, now what will happen? The lone pair of electron will try to attack on the electron deficient species. Now, what will have? Watch carefully. You have CH3 bond CH bond CH3 bond CH2 bond. Now, I'll draw it in a different way. Here we have hydrogen. Here we have another hydrogen which came extra, which gives this oxygen a positive charge. Now, as you know, I know you know because you are smart guys, right? So, whenever oxygen has a positive charge, it's very unstable. Yes, because oxygen is not very good in keeping a positive charge. So, what oxygen will do? Oxygen will try to make it more stable by breaking one of the bond. Okay, now that's very important part. If things get too much to deal with, you have to break things to make it simpler for you. That's life, right? And they are just like us. They are gonna behave like us. So oxygen decides to break a bond. So this bond will be broken, and water molecule will set free. Okay, so here what will happen? Here we see, let's say minus H2. The water is removed from the system. So what remains is CH3 bond CH bond CH3 bond CH2, and of course a positive charge, because now CH2 is electron deficient. Here there is a formation of carbocation. Now most of the students, what they do after this stage, they bring in the chlorine, attach here, and there goes the product, and there exactly, that's how you lose your marks. But what we'll do, we are smart and we will understand what not to do. Now at this stage, wide your eyes, look carefully. You have a carbocation which is primary, and primary carbocations are not that stable. So what this molecule will try to do, this molecule will try to make it more stable. Every molecule try to attain stability. And how they will attain stability? By a phenomena called as hydrogen shift. What will happen here? This hydrogen shift will allow this hydrogen to move to this carbocation, converting it into a more stable carbocation. That is, watch carefully. Since here we are doing the hydrogen shift, or we can say the proton shift, I'll draw it like this. And here you have CH3 bond C. Since the hydrogen is moved, you have CH3, and here you have CH3 again, since it has an extra hydrogen, and now here you have the positive charge, which makes it a tertiary carbocation, a stable carbocation, right? Yes, that's the important part. Now what will happen? Now you will bring in the chlorine. Okay, so here what happens? The chlorine comes in, Cl minus, attacks on, of course, this part to give you a very simple molecule, that is alkyl halide. So this is the process by which an alkyl halide is formed by using alcohol. I hope you understand. It is very simple. The only part you will going to be focused on whenever there is a formation of carbocation, look around the molecule. If one hydrogen shift can bring you a more stable carbocation, and if you find out, do it. Get your marks, snatch it from them, because that's what we are here for, to make you understand how to get good marks. Alright, so here we have understood the reaction of alcohol with an acid.